Okay, so I don't know if you remember last time I had suggested that you could try this question, the do now 6.1. I had suggested that you could try that question for homework, but I don't know how many of you would have had a chance to do that. Hi, Sihle. Hi, Zayan. Hi, Katlejo. Kelebukile. Ria Betswe. Tutuka. So nice to have you guys all back. You can't hear me. Okay, we'll have to ask Tula to sort that out. Okay, Sam? I know tonight is our last night on this course. Can you believe it? Hi, David. But it's cool because we'll see each other again on the... Hi, Daniel. Yeah, I did, didn't it, Zayan? So quickly. Can you believe it? We've been doing this now for 4 weeks. This is our 8th lesson already. Anyway, sorry, I mustn't talk. You guys need to work. I beg your pardon. As I was saying in the beginning, sorry, I'm being too chatty now. Oh, thanks, Nalwazi. Thanks, Katlejo. Those are such nice messages. All right. So question 6.1 was something that I left you with the last time. Did you guys manage to do that for homework? If you didn't, it's not a problem at all. We're going to work through it now. I just wasn't sure if anybody had had a chance to do it yet. Is there anybody who did manage to do 6.1 for homework? You can give me a thumbs up, please. It's okay, Zayan. Don't worry. It's okay. Okay, David, you couldn't manage. It's fine. I understand you guys have got a lot going on. It's all right. We can do it now. Marisa, did you do it? Oh, well done. Okay, that's wonderful. That's fine. So we'll mark it now. Everybody else, you just work in the meantime. Well done, Marisa. That's great. So you can mark your answers shortly. Okay, so yeah, if you haven't done it, then get started on that now, please. Just make it a little bit bigger. There we go. Okay, so I'll give you guys just one more minute and then hopefully everybody will be here and we can get going. You're struggling a little bit with the second question. That's okay, Phoebe. Tell you what then, if you're struggling a little bit, I wonder if there's anybody else who's having a problem. What we can do is we can get started on working out what the answers are. Okay. All right. So if that's all right with everybody, David, you stuck. Sorry, ma'am, what are we doing? Okay, so Sam, can you hear me now? We're working on question 6.1. Let's do this together, and you can mark whatever you have got, and then whatever you haven't, you can hear me. Oh, brilliant. Okay, and then whatever you haven't managed to finish, you can just copy down. Okay. All right, so Phoebe, not to stress, 6.1.2, we'll get there now. Okay, so in 6.1.1, the range of P, did anybody have an answer there that they would like to suggest? Did anybody write anything that they want to share with us? Don't be worried if you get it wrong. It's no one's judging you. Anyone try that? You said 2, you think. Okay. Why did you think 2? Is it because of this 2 over here? Is that why you thought maybe it was 2? All right. So do you remember grade 10s? You think it's 0, David. Okay. All right. Why do you think it's 0? Okay, Marisa, so I know where you got the 2 from now. So David, why did you think 0?
I think it's 0 because 0 is the range.
Okay, but the word range, what does it mean? What does it mean, David? Can you remember?
Y value.
Well done. Okay, so that's perfect. So the range is, sorry, quite, so I'm not saying the right thing here. Range is the Y values, the outputs. Okay. Now, they've told us here that the horizontal asymptote is at the line y equals -9. Okay, so this graph, Nolwazi, there we go. All right, so this graph cannot go through the line y is -9. It can keep going on up and up and up and up to positive infinity, but it can't get through the line y equals -9. So what we were supposed to say here is that y is greater than -9. Okay, not equal to, just greater than, okay, because the line y equals -9 is an asymptote. So that's the value of q. Q in this case is -9. All right. Do you also see here, grade 10s, that instead of using the letter B for base, what letter have they used? They've used a?
Ma'am, I think they used...
Yes, that's right. They used a K. Perfect. But that's not going to put us off. Okay, we know that letters are just there to represent unknown numbers. And if they use a B, it's fine. And if they use a K, it's also cool. We know exactly what they mean. All right. Look here, grade 10s. It told you that K is greater than 0. And it told you that K can't be 1. All right. So that means that K has to be 2 or 3 or 4 or 5 or something like that. So in other words, this has got to be, I'm just going to do a little baby sketch over here. It's got to be our classic J-shaped exponential function. Okay. And then down here at the bottom, this is where the line y equals -9 would be. But anyway, we're going to draw it now. So I'm just pointing that to you. Okay, so now, Phoebe, you said you struggled to determine the equation of P. So now that I've given you a hint about the value of Q, where would you put the Q? Or what would you write in place of Q in your equation, Phoebe?
It's a 9, sorry.
Quite right, I agree with you. So we would write down P of X, which we know means Y, is equal to K to the X minus 9. Perfect. All right. Now remember, if we want to work out what K is, we need an X. We need an X and a corresponding Y. So there is our X. Okay, our corresponding Y. Yes, my love?
Ma'am, the PQ, does it stand for Y?
Yes, P of X.
Oh, okay.
Yes, P of X means Y. Absolutely, absolutely. Okay, so P of X means Y, just like F of X means Y and G of X means Y. P of X means 1. I don't know. I don't think I've done you much justice there with one being in orange and the other one being in red. But anyway, so here's the red one. Okay, so now what I want to do is I want to replace Y or P of X with 0. And let's just go back to purple. I want to replace the orange, the X with 2. And now I can write down the rest of it, -9. What am I going to do now, grade 10s? What should I do now?
Take the 9 to the other side.
Indeed.
And it becomes a
Keep going. It becomes a
plus. You plus
perfect.
it.
Perfect. 100%. So 9 is equal to K squared. So now the $1 million question, what is the value of K?
1.
What's the square root of 9? What do I need to square root both sides?
3.
There we
3.
go. Okay, so we would have 3. Happy with that? 3 times 3 gives us 9. Okay, good stuff, Nalwazi. That's perfect. Is everybody else satisfied that the answer would be 3? Thumbs ups, thumbs downs. How are you feeling? Yes. Okay, Zayan, cool. Everybody else, Phoebe's fine. David's feeling better. Good stuff. How's everybody else? Marisa, good. I was just about to ask you how you are. Kelebochile, is that making sense? Riabetswe, Sichle, Naleti, you guys are quiet. Oh, there we go. You've put, okay, cool you. Katlejo, not at all. Oh, I'm so sorry. Okay, maybe when everybody else is busy on the next question, Katlejo, we can go back over this again. Okay. No problem. Okay, so everybody else is feeling pretty good. Ria Betsway, you've just asked me, ma'am, can I ask why we put -9? Okay. Ria Betsway, what we've got to always remember, okay, Nailet, you got a nice smiley face. That's cool. All right. So just very quickly to answer your question, all right? Your exponential function comes in the form y equals, if you remember, base to the power of x plus q. So this number on its own, the constant term, that always represents the asymptote. If the graph has been shifted down, like it has in this case, it will be a negative number. If the graph has been shifted up, then it will be a positive number. So that's why we've got to put the -9 over there, because that is what it means. Q means the value of the asymptote. Okay, so that's why we started off. If we know the value of the asymptote, it's always the first thing that we sub in. And then we take another point that we've been given that lies on the line, and we sub in for x and y, and then we can solve for the unknown, which in this case would be b. In this case, we've called it k, but it's exactly the same idea. Okay, oh, good stuff. I'm glad you remember now. Okay, hopefully that's feeling a little bit better. Okay, so Phoebe, back to what you said in the beginning. You said that you were feeling a little bit stuck with how we would determine the equation. So the last thing that we need to do here is we need to answer the question, all right? So we have to then say here, sorry, I'm squashing it in down here at the bottom, which is not awesome, but anyway, hopefully you guys can see. Okay, so P of X is the function. Instead of K, we're gonna write 3 to the X, and in place of the plus Q, we're gonna write minus 9. Okay, is that making sense? I hope so. Is everybody happy with that? All right, so then the next question, 6.1.3, right? Now they want us to draw a sketch of the graph, right? Clearly show the intercepts with the axes and the asymptote. Okay, so do you remember those 3 marks? The 3 marks we see here. do red. These 3 marks here. Shape, X and Y intercepts labeled correctly. And the last mark is for the asymptote, drawn and labeled. Okay, so now you need to know, because your base is 3, your graph, as we had discussed earlier, is going to be J-shaped. All right, so I've already drawn this. I'm going to take you to where I had drawn it up here, just to save us a little bit of time. And there we go. Okay, so what we still needed to do is we needed to work out the x-intercept. Well, no, we actually didn't have to work out the x-intercept. They gave us the x-intercept. But we needed to know what the y-intercept was. So this little bit of information here, this bit of working that I've done here, this was actually given to us. If we go back and look at the information, I'll just steal it and bring it up here. Right? They told us, they actually said to us over here on the left-hand side that the x-intercept was -2. So I didn't actually have to work that out. I just did it. All right, so there's the x-intercept at 2. How do we find the y-intercept? Can you guys remember? I mean, you can see it there in front of you. We have to let
X be 0.
Beautiful. Okay, you've got it. Okay, so we let x be equal to 0. Anything raised to the power of 0 is?
1.
Amazing. Beautiful. Okay, so 1 minus 9, we'd end up with -8. Okay, so now, why am I not going to get full marks for this? I was naughty. What did I leave off grade 10s?
The asymptote number.
That's right. Okay, there we go. Okay, so now I've got a mark for my shape. It's an increasing function. I've got a mark for my x and y intercepts, and now I've got a mark for my asymptote. Okay, is everybody happy with that? Okay, cool, Rebets. Where everybody else, how are you feeling? I know you're obviously busy writing. It's a bit difficult to write and type on your phone, but maybe when you've got a chance, you can give me a thumbs up.
Ma'am, I don't understand what y is. Like putting it on the graph.
Okay, when you say y, do you mean -8? Or,
Wait, sorry, ma'am.
Or do you mean where I've written in pink?
No, ma'am, I meant J, like the graph. When you had to put on the graph, how it looks.
Oh, okay. So did you mean you didn't know what shape the graph was supposed to be?
Yes, ma'am. I don't understand when you say J.
Oh, okay. All right. I'll explain that to you again. All right. So Zayan, we can certainly go over it again. Naileti says she doesn't understand. Okay. Not a problem. Me too. Fine. No stress. This is something that you have to learn. Okay. Let me just put that over there, right? Let's just go through this one more time. When we are talking about exponential functions, your function will always take the form y equals the base to the x plus q. All right. As we've already chatted about before, and I have got no problem explaining again, this number over here, this plus q, is always the value of your asymptote. Okay, remember exponential functions have horizontal asymptotes. Hyperbolas have vertical and horizontal asymptotes. So for hyperbolas and for exponential functions, q is not a y-intercept or a turning point. It's the asymptote, right? The question was really about this, okay? So let's just consider the values that b can be, all right? B cannot be 0. right? Because we can't have a function that is 0 to the power of x, all right? That isn't going to do anything to our line. Our line isn't going to be able to increase, because if I have 0 and I raise it to the power of 1, it's still 0. If I have 0 and I raise it to the power of 2, it's still 0. If I have 0 in the power to 1,000, it's still going to give me 0. So all my line is going to do is it's going to do that. It's not going to increase, right? So we can't have b being equal to 0. We also can't have b being equal to 1. Because if I have 1 to the power of 2, it's still 1. If I have 1 to the power of 10, it's still 1. If I have 1 to the power of 1,000,000, it's still 1. Okay, so it's the same problem that I have with 0 is the same problem that I have with 1. Okay, so your base number can never be 0 and it can never be 1. So that means there's only two things that and it can't be negative, right? It cannot be negative. B can also not be smaller than 0. So that means that there are only two things it can be. Either it has to be a number that's bigger than 0 but smaller than 1, or it has to be a number that's bigger than 1. Okay, those are the only two options for B, all right? Either B is a fraction, so between 0 and 1, or B is bigger than 1. Now, these two things make a difference, right? If a graph has b greater than 1, so in other words, y equals 2 to the power of x, or y equals 3 to the power of x, or y equals 7 to the power of x, in all of these cases, grade 10s, the base number, which I'm underlining in green, is bigger than 1. So what I meant when I said that they are J-shaped, I was trying to say this. They all do that in shape, okay? So when I say J-shaped, when I write a J, I do that. So that's like the asymptote. Does that make sense now when I say J-shaped? I'm talking about this over here specifically. Does that make a bit more sense now? Okay, so this is what we refer to as an increasing cool beans. So this is what we refer to as an increasing function. And what the word increasing means is, imagine you, okay? You are now standing over here, and you want to walk that way, all right? Are you walking downhill?
No, ma'am, you're walking uphill.
You're walking uphill, aren't you? I mean, by the time you get here, you're already crying and wishing that you didn't have to go up this hill. But if you go in that direction, it's getting steeper and steeper. Okay, so when something gets steeper, we use the word increasing. All right, so in other words, the steeper we go, or the further to the right we move, the steeper it becomes, all right? So this is also called having a positive gradient. So J-shaped exponential functions are increasing because they have a positive gradient. In other words, if I was to connect this point over here to that point over there and draw a straight line, can you see my line has a positive gradient? Does that make sense to you? I'm sloping up to the right. So that's something that all these functions share. So if b is greater than 1, they'll look like that. Now, the only difference between y equals 2 to the x and y equals 3 to the x is one is steeper than the other. So if this graph over here is y equals 2 to the x, y equals 3 to the x is even steeper. And y equals 7 to the x is steeper still. Okay, so that's what changing this base number does. Okay, it makes the graph steeper or shallower as the number comes down. Is everybody okay with that? So this is something you have to learn, as opposed to functions where b is a number greater than 0 but smaller than 1. So when I say that a number is greater than 0 but smaller than 1, I'm saying that b is a fraction. So in other words, I could have the line y equals 1 over 2 to the x, or I could have the line y equals 1 over 3 to the x, or I could have the line y equals 1 over 7 to the x. Okay, now these graphs here are not J-shaped. They are not increasing. This is what they look like. Okay, so they do that. Okay, so if you are now standing over here and you were moving in that direction, okay, when we're moving to the right, Sneh, you can't see anything. Tudor, can you still see? Can everybody else still see what I'm doing here?
Yes, ma'am.
You sure? Okay, all right. Okay, so maybe Tula will be able to help you, Tandeka. Okay. Oh, all right, cool beans. Okay. So now when I'm standing over here and I'm walking in this direction, I am now going downhill, aren't I? Okay, so my gradient is decreasing. This is a decreasing function. Okay, because y is getting smaller. As I walk to the right, I'm also walking down. Does that make sense to you? All right, so as I walk to the right, I'm also coming down. Over here on the other side, as I walk to the right, where was I? I can't remember where it's gone to. As I walk to the right, I'm walking up. Okay, so if I start up here and I walk to the right, I'm walking down. That's why it is a decreasing function. Okay, so this is what I was saying to you the other day. Now, these are just names that I've given them, all right? It's not actually called a J-shaped exponential function, but I'm just trying to explain the shape to you using something that's familiar like a J, right? What does this look like? I don't know. I've always thought that that sort of looks like a C a little bit. All right. But as I say, that's not actually its name. All right. This is a decreasing function. All right. So either B can be a fraction or B can be a number that is greater than 1. So that's something that you have to learn. So if you've now come over here, where's our question? Where did it go? It's somewhere up there. Okay, so now you come over here and we answer this question, all right, and we solve for K, and we worked out that K was equal to, where was it? Over here. K was equal to 3. Immediately you have to know, okay, so this B value, also called K in this question, this B value is bigger than 1, it's 3. So straight away, I know what shape this graph has to be. It has to be an increasing function. Does that make a bit more sense? Yes, Naileti, a decreasing function has a negative gradient. Quite right, 100%. That's exactly it. So decreasing means negative gradient, increasing means positive gradient. Okay, so decreasing, we're moving to the right and we're moving down. Increasing, yes, that is correct, Marisa, 100%. Okay, so for a J-shaped one, what I'm doing is I am still moving to the right, but instead of going down, I'm going up. That's why I use the word increasing. Is everybody all right with that? Those words are super important to you. Not so much in grade 10, but you're going to see next year in grade 11 and grade 12, knowing what increasing and decreasing is and what it means is important. So that's how I knew what shape my graph had to be. I also knew that I had to have an asymptote at -9. So the first thing that I want to do when I draw a graph with an asymptote, so if I draw a hyperbola or if I draw a an exponential function, the first thing that I always have to do is draw the asymptote. So here I'm drawing a really bad set of x and y axes. So now I know that my asymptote is the line y equals -9. So that has to be down there. If you recall from our calculations, we worked out the y-intercept to be 0 and -8. And they told us what the x-intercept was. They told us that it was 2 and 0. So now I know that -8 on the y-axis has got to be somewhere over here. 2 on the x-axis has got to be somewhere over there. So that means that my graph has to do, okay, that's not a very good, it's supposed to be a smooth curve. That's not a great shape at all, but it's going to be an increasing function. Label here, and we're done. How do you feel now? Any questions?
Ma'am, can we do another one? It's already past.
It is, quite right. Okay, let's move on. Okay, let's go and have a look. Would you like to do, so I'll put the choice in your hands. Would you like to do something quite a bit more difficult where we're working with a quadratic function and an exponential function? Is that okay?
Yes, with you though.
Oh yes, with me, with pleasure, no problem. All right. Okay, Ria Betswe, let's do this. I have got another exponential function, but this is a really nice question because it combines two things that we've already done together. All right, so let's get cracking on this. Okay, so the first thing that we want to do is read the information. All right, so it tells us, sketched below are the graphs f of x equals ax squared plus q and g of x equals 1/2 x minus 4. Now, based on the discussions we've just had, that should make sense to you with what you're saying, okay? The C shape, the decreasing function. The first thing that they want us to do is they want us to write down the coordinates at D. Okay, so what does D represent? There's D over there. What is D? D is
the y-intercept.
Indeed, the y-intercept of which function? F or G?
It's the y-intercept of G, ma'am.
It is. Okay, so it's the y-intercept of G. All right. How do we work out a y-intercept?
X becomes 0.
Exactly. Okay, so G of x or y equals 1/2 to the 0 minus 4. Okay, so the value of y when x is 0 is equal to? What's it equal to?
Sorry, ma'am, please repeat that.
So in other words, what I'm asking you to do is solve for what's on the board. Okay, so 1/2 to the power of 0 is 1. 1 minus 4 leaves me with a y of?
3.
-3. -3? Here's the x-axis. A and B are points on the negative axis. So D is below the x-axis. So D has to be a negative number. All right, so the coordinates at D, I would write as follows. 0 and -3. Next question. Look, there we go. There's a range question again. The range of G. Okay, so based on the discussions we've had, this should be a little bit easier for everybody. All right, what should I write here? What's the range of G? Anyone want to give that a go? Okay, David, we're going to write down what the range of G is. Okay, the word range means the Y values. So what would the range be for G of X or for G? We've spoken about this lesson.
Is it -4, ma'am?
Indeed, but what -4? Y equals -4, bigger than -4, smaller than -4?
Smaller than -4.
-4.
Say again.
I think it's y greater than -4.
Perfect. Okay, greater than -4 because the function sits above -4. It can't go through -4. So Y, all your output numbers are going to be bigger than -4. All right, so perfect. Okay, next thing. Calculate the coordinates of A. All right, so what does A represent?
Isn't it the x-intercept of graph G, ma'am?
It is. It's the x-intercept of graph G. Quite right. Okay, so how do we find an x-intercept? We've got to let?
By letting y equal to 0.
Good. So 0 equals 1/2 to the x minus 4. Okay, so now this becomes a little bit more difficult. What should I do with the 4?
Sub.
Take it to the other side. It's going to
Take
be
it
4
to-
equals to 1/2 to the power x.
Beautiful. Now what am I going to do? You're on the right track. There's just one more thing that we need to realize here. What are we going to do? So this is where we need to know our exponent laws so very, very well, all right? Remember, if we want to solve for x as an exponent, we have to make the bases the same. So I can rewrite 1/2 to the x as 2 to the power of -x. And I can write 4 as 2 squared. Now that the bases are the same, I can make the exponents the same. And that means that x has to be equal to -2. Everybody happy with that? Okay, that's the hard step. Okay, so 1/2 to the x is the same as 2 to the power of -x. Okay, using our negative exponent rule. Okay, so that means for us that, just move that out the way, that the coordinates at A are, sorry, let me just move this thing again. No, that still doesn't help me. Okay, the coordinates at A are -2 and 0. And again, it makes sense that it would be -2 and 0 because look at where A is. A is on the x-axis to the left of the y-axis. So x must be a negative number. So I'm feeling confident that I've got that right. Okay, let's move on to the next thing. Are there any questions? Is everybody happy? Is this making sense? Any questions? No? All right. So now here's something from our second lesson. All right. Calculate the values of A and Q. So now you've got to remember back to our second lesson together and also to anything that your teachers have taught you at school. and work out the values of A and Q. Can I let you do that by yourselves? Is that all right? Thumbs up, thumbs
Yes.
down? Is that okay?
Yes, ma'am.
Okay, all right. So you give that a little try. Perfect. And then we'll talk about the answer now. If there's anybody that finishes 5.2 and you want to go on to 5.3 or 5.4, you're very welcome. Okay, so I'm just checking in. How is calculating of A and Q going? Marisa, your screen is blank. I don't know why. Tula, I don't know why this is happening tonight, where we're getting blank screens.
I'm not sure. Can everyone just confirm maybe on the chat so we see if is this happening for most people or not? Can you guys see the screen? Just maybe thumbs up or something.
Karabo, no. Erickson says he can see. Erickson, have you managed to work out an answer for A and Q yet? Are you struggling, grade 10s? Can you manage to do A and Q, or do you want me to jump in and assist you? Just being mindful of the time. Okay, you're still working on it, all right? Do you want me to jump in and assist you, grade 10s, or do you want me to leave you for a little bit? Okay, Katlego. All right, so if you're doing your own thing and you want to get to the answer on your own, then you're very welcome to continue working. I am going to assist. Okay, so Katlego, can you see that you have 2 points that lie on the parabola? You know what the coordinates at A are, right? We worked them out in 5.2.1. So we know that the coordinates here are -2 and 0. So we've got a pair of coordinates at A, and we've got another pair of coordinates here at E. So what we're going to have to do in this case is we're going to have to sub both pairs of coordinates into the equation and then solve simultaneously. So that is something that your teacher should have shown you at school, but it is something that's a little bit more difficult, okay? So in other words, what I'm going to do just moving that over, so I've got a little bit of space here to write, is I'm first going to sub in the point -2 and 0 into f of x equals ax squared plus q. So remember, this is my y, so I'm going to replace f of x with 0. And -2 is my x. So a, open brackets, -2 squared plus q, right? So that means that 0 equals -2 times -2 is 4, and 4 times a is 4a plus q. So this means that q, I'm going to take the 4a over to the other side, it will be equal to -4a. That is equation number 1. Now I'm going to repeat the process. Let's do it in a different color. And now I'm going to sub in the other point that lies on the line, 1 and 3. So in place of f of x, so over here, I'm writing 3. In place of a, I don't know what a is, that's what I want to solve. In place of x, I'm writing 1 squared plus q. So now I have another equation, and it reads 3 equals 1 squared is 1 times a is 1a plus q. And that is equation number 2. So you learn how to solve simultaneously in grade 10 for specifically this reason, so that you can answer questions like this. So now I'm going to solve by substitution. So what I want to do is I want to replace the q over here with what q is equal to in terms of a. So I'm going to write 3 equals a, and instead of q, I'm going to write -4a. Right? So in other words, what I'm doing is I'm subbing equation number 1 into equation number 2. Remember, I can't solve for 2 unknowns in one equation. Now that I'm working in terms of the same letter, I'm able to solve for a. 1a minus 4a is -3a, and that means that a has to be equal to -1. All right, so I divide both sides by -3, and that's why a is equal to -1. Now that I know what a is, I can go and sub back in and I can work out q using equation 1. Okay, so up here, using equation 1, I can say that q equals -4 times a, and that means that q is equal to 4. So you should have got a is -1, and you should have got q is 4. Is that making sense? Okay, so David, you say no. Katlego, yes. No problem. Anybody else? Anybody else got feedback? How do you feel about that? Naileti, no. Sam, you said yes. Okay, Daniel, also a yes. Okay, so this is something that you have to practice. Right, this is a little bit more difficult than what we had done, but that's why I'm doing it with you now to show you how to do this. Have you all solved simultaneous equations at school?
Yes, ma'am, but I didn't understand.
But you didn't understand. Okay, all right. Okay, that's good. Okay, Nkaniso, thank you. Yes, ma'am, though I did not understand. All right. So I just don't want to waste anybody's time, but am I correct then that there's more people that are saying no than what are saying yes? So in other words, what I should try and do is go through this again. So you can copy the numbers. Okay, Katlejo. Right. So Katlejo, I'm going to do this again. All right, because people are struggling to understand what it means. Okay. So I'm gonna, well, maybe I suppose I don't have to rub that out. But yeah, let me do it again. All right. If you do feel that you understood it and you would like to carry on with something else, we've only got 8 minutes left, but you are certainly more than welcome to do 5.3.1 or 5.3.2. Let's just see where we end up. For those of you that didn't understand, I'm going to explain it all over again. Okay. And I just want to get rid of this over here. All right. But don't stress. I'm going to write this all over again. Okay. So simultaneous equations in grade 10 is a section in algebra where you get given two equations and there are two unknowns in both, and you have to use the one equation to help you solve the other one. All right. This is more difficult, what we're doing now, because they didn't give you the two equations. You've got to actually make them yourself. All right. And in functions, we make equations by subbing in the information that we've been given. All right. So if we go up and we go and have a look, all right, they want us to work out the values of A and Q. A being the shape and Q being the y-intercept. In other words, what the coordinates are at C. All right. So when we solve for this Q over here, it also tells us what the y coordinate is over there at the turning point. All right. Because the graph is concave down or sad face, we are expecting A to be a negative number. If we got a positive number, we would know that we've done something wrong. Also, we can see that at C or Q, this y-intercept, that's above the x-axis. So that's got to be a positive number. So I know A must be negative, and I know that Q has to be a positive number. Okay, this is part of the learning that you have to do. So what we're going to do, we've got two equations that line line. That's the only information that we've got. We know this bit of information over here. Okay, so 1 x-intercept is -2 and 0. And we know this bit of information over here is 1 and 3. There's nothing else. There's no coordinates given to you here. There's no coordinates given to you there. So the only thing that you can do is sub in the points that you've got. Right? So if I decide to first sub in the point 1 and 3, x is 1 when y is 3. So f of x, y is ax squared plus q. X is 1 when y is 3. So I'm replacing the y with 3. I'm replacing the x with 1, and I'm squaring it. And then I'm adding q. So 3 is equal to 1 times 1 is 1, and 1 times a is a plus q. There is your first equation. In terms of a and q, your two unknowns. We got that from subbing in the point 1 and 3. Now we're going to do exactly the same thing again, except we're subbing in the other point that we've been given. All right, so I'm going to change color and now into exactly the same thing. So into this over here, the same equation. All right, I am now subbing the point -2 and 0. So x is -2 and y is 0. So if I've got f of x equals ax squared plus q, the equation of my parabola, let's just move this up. X is equal to 2 when y is equal to 0. Okay, so 0 equals a, open brackets, -2 squared plus q. So that means 0 is -2 times -2, because that's -2 squared, is 4. 4 times a is 4a, and 4a plus q is equal to 0. So I did this by substitution. You can also solve linear simultaneous equations by elimination, but I thought that substitution would be easier for you. Okay, so now I want to substitute, right? So what I'm going to do is I'm going to leave q, this q over here, I'm going to leave it on the right-hand side of the equation. And I'm going to take the 4a over to the other side, and that gives me -4a. Because I rearranged equation 2, I have to sub back into equation number 1. So what I'm doing is I am replacing the q in this question with what q is equal to. So 3 equals a, and I'm replacing q over here with what q is equal to, in other words, -4a. Now I've got an equation that only has one letter in it, because I can't solve for more than 2 unknowns in one equation. All right, so now I'm going to say a minus 4a gives me -3a is equal to 3. Divide both sides by -3, and that's why a is equal to, whoopsie daisy, -1. Okay, so now that I have the one letter, now I take that and I sub back in, right? So I now want to substitute back in here. I'm going to take this and I want to sub it in there so that I can work out q. So q is equal to -4 times -1. And that's why q is equal to 4. I hope that makes a little bit more sense. How are you feeling, grade 10s? Sure, Katlego? Okay, yes, this is something that you do have to practice. Okay, this is difficult. I know it's difficult, but I also can't not show you what's going to happen. You know what I mean? I've got to show you the sort of questions that they're going to expect you to be able to answer. I mean, this question here comes out of a grade 10 national paper. So take it up again, Katlego. Where as far as there? You understand? Okay. But yes, this is something that you do have to practice. Katlego, I hope that's up enough for you. Now, I'm afraid grade 10s, I've got to go. It's a pleasure, Naileti. It's a pleasure, Katlego. I'm glad. All right, all I want you to do is to understand and be able to make progress. Now, I'm sorry, I'm going to have to hand you over to Tula. I've got to go and give him a trick lesson now, but I'll see you guys again when we start Treg, okay? So look after yourselves and thank you for being so amazing. All right, best of luck. Bye. Bye.
Hi, Lee.
Bye.
Yeah, my grade 10s. I'm just going to quickly go through a few announcements and then and let you go to enjoy the rest of your evening. Let me just quickly screen share. And of course, as usual, if you can't see my screen for whatever reason, just leave a thing on the comment section, and always just try to give more information on what's actually happening. I want to tell you guys, I think someone asked about this on Tuesday. The mentors, the Watobi mentors, the learning coaches, they have the maths anxiety workshops happening on Fridays at 6 p.m. And remember, this is not a maths, it's not a maths lesson, so you don't need to come like with your maths energy and whatever. So even if you've had a long day and you're tired, you can just come and be having your coffee or your cup of tea or whatever. You don't need to come with your stationery. You can just come and listen and interact with other Watobi learners. Remember that Watobi is national, so we have learners from like every province. So it would be cool to kind of talk to other students and hear how they study, how they deal with math anxiety, how they deal with stress during exams, like what are their thoughts. And it's open to from grade 10s until grade 12. So you can talk to people of different grades. So which I think is pretty cool. So make sure you guys join. On your Watobi app, you should already have the link there. But if you don't, then send a message there and just ask for the link tomorrow. And then someone will be there to assist you. And you guys mentioned that you couldn't see the screen. I'll look into that and try to make sure it doesn't happen next time. I'm not sure what exactly was the issue, but we'll look into it and try to make sure it doesn't happen. And but also remember that these are being live streamed, like I showed you last time on watobi.co.za. So if there's anything that you missed, maybe wasn't on the screen, maybe the teacher went by too fast on the slide, you still need to copy something, just go to watobi.co.za and get the lesson, and then you can be able to see everything. Okay, so today was our last lesson on functions and graphs, and then we are moving on to trigonometry on Tuesday. So on the 24th. So you guys make sure that you come prepared for that. And this is going to be our lesson schedule for trigonometry. So I know some of you have started this in school, some have not. It's all okay. And then just to prepare for that, make sure you go to the Watobi app, and then for lesson 1, go to trigonometry. After trigonometry, go to trigonometry basics, and then just watch the lessons on these two. So watch the lessons on these two segments, the intro and the naming and using, and then try to do what you can. You don't need to understand everything before you come to the lesson, but it helps when you come with already, you know, a bit of understanding, and you know what you want to ask, and you know the approach to everything. So yeah, I think I'm done for now. So I think I'll let you guys go. Does anyone have any questions on anything I said, on any system issue, any functional issue, something you don't understand? I'll take that as a no. Okay. You guys enjoy the rest of your evening. I'll see you hopefully tomorrow for the math anxiety. Katleho, are you asking which class? The next class that we have for trigonometry. That's going to be on Tuesday at 5 p.m. But for math anxiety, the workshop with other Watobi students and the mentors, it's going to be tomorrow at 6 p.m. So tomorrow on 6 p.m., you'll find the link on your chat on the Watobi app. We'll also send you a reminder tomorrow. Okay. You guys enjoy the rest of your evening. Goodbye. Bye.